the fundamental theorem of calculus, or definite integral. The fundamental theorem of calculus says if we have a function f that is continuous on a closed interval ab, then the definite integral of f exists on that interval, and it is the integral from a to b of the function f of x dx is equal to the antiderivative at b minus the antiderivative of f at a, such that f is a function that is differentiable, and the differentiation of the function f is the lowercase of x on the interval ab. So how do we apply that? We know how to integrate. In this case, it is a definite integral, and the theorem says after you find the antiderivative, you're going to substitute 4 in the first antiderivative minus substitute 2 into the antiderivative and doesn't subtract. So to do that, we're going to first find the antiderivative of x cubed plus 4. We know that this is equal to the integration of the first one plus the integration of the second one. Basically, this is the integration of 2 to 4 of x cubed dx plus the integration of 4 outside of 2, 4, 2 to 4, 1 dx. And this is basically equal to x to the 4th over 4 plus 4x, and then we have to find this from 2 to 4, meaning first we're going to put the antiderivative, plug 4 into the antiderivative. This will give us 4 to the 4th power over 4 plus 4 times 4. So this is the first antiderivative when I plug 4 in it, minus the antiderivative again when I plug 2 to it. So this is 2 to the 4th power over 4 plus 4 times 2. And then you can find the final answer here. So we have 4 to the 4th divided by 4 is 64 plus 16 minus 2 to the 4th power divided by 4 is 4 plus 8 is 12. So we have here 80 minus 12, which is 68. And that is the final answer. Notice how the final answer has to be a number. And usually that number is a positive number because it represents the area under the curve from one value to another value. Here's another example. To find that, we're going to integrate as usual. So the integration of the first part is 3x to the 3rd power divided by 3. Plus 6x squared divided by 2, and now we need to find it from 1 to 3. So we're not going to add the constant because this is a definite integral. This is basically equal to x to the 3rd power plus 3x squared from 1 to 3. This means you're going to plug 3 into the antiderivative minus when you plug 1 into the antiderivative. So this is basically 3 to the 3rd power plus 3 times 3 minus, this is the first part, minus when you plug 1. So that is 1 to the 3rd power plus 3 times 1. Here is a square right here. I forgot it. So the final answer will be 27 plus 27 minus 1 plus 3. So this is equal to 54 minus 4, which is equal to 50. And that is the final answer. Here is another example. In this case, notice how we have two integrals, and one of them is going to be computed using the substitution method. So first, we need to distribute the x inside. So we will have the integral from 3 to 5 of square root of x squared minus 9 times x dx, that is the first one, plus the 2 out, integral of from 3 to 5 of x dx. I could have just kept the 2 in there, but I chose to take it outside right away. Now notice I can find the integration of this easily. I don't have any problem. In this case, I need to use the substitution method in order to solve it. In this case, I'm going to say I'm going to assume that u is equal to the amount under the radical, x squared minus 9. That will give me du is equal to 2x dx. Notice how I have only x dx in this integration. I don't have the 2, so I'm going to divide both sides by 2. These will cancel. Now I will substitute everything here with u, so I'm going to say this is from 3 to 5 of the square root of u, and then du over 2. With a 1/2, I can kick it outside of the integral and then integrate as usual. I can turn the square root into a power of 1/2. So this will become the 1 over 2, the integration from 3 to 5 of u to the 1/2 power du. And then I will integrate this as usual. This will become 1/2 u to the 3 over 2 over 3 divided by 2. The denominator of the denominator becomes a numerator. So I will have 2 over 2, which will cancel. So this is from 3 to 5. This will become 2 over 2. They're going to cancel. U of 3 over 2 over 3 from 3 to 5. Now I have to substitute u with this value, which is this amount right here. So this is going to become, I'm going to write it here. So this is going to become the square root of the u, which is x squared minus 9, all to the 3rd power over 3 from 3 to 5, and then you find that answer. I will do it right here after I find the second integration. So the second integration is a basic integration. This basically is going to be 2, and then the integration of x is x squared over 2, and that's from 3 to 5. The 2 is going to cancel with 2, and I will have only x squared from 3 to 5, which is basically 25 minus 9, which is 16. So in this case, I'm going to find the answer. This is going to be the square root of 25 minus 9 all cubed over 3 minus the square root of 9 minus 9 all cubed over 3. This is equal to 0, and this is 16 cubed under the square root, which is going to be 16 times 4 over 3. So the final answer should be 64 over 3 plus 16.